Hello, this is Professor Wood coming to you from the Center for Energy Education. Today we're practicing a little bit of social distancing, so we're working from home, as many of you are, I'm sure, doing your schoolwork from home. I wanted to get back with you this week and pick up from our lesson from last week when we talked about what is energy and what is renewable energy. You remember last week we had a little lesson before we did the solar ovens on energy and the types of energy and so on. And now I want to continue on with that about renewable energy. We decided last week that this piece of wood is an example of renewable energy, but is it the best example of renewable energy? So we're going to do that through a little video that's provided to us by the folks at SciTunes and Brown University, and we'd like to thank them very much for their effort in helping us. So the video is about 5 minutes. It's going to start out with what is solar energy, and hope you enjoy it, and I will be back with you then after the video is over to talk about various forms of renewable energy. Thank you.
Solar energy. Did you know that all of the energy we use comes from the sun? You probably know that's true for solar panels, but the sun is also the ultimate source for energy generated by wind, water, and fossil fuels. It works like this. Heat from the sun drives the air currents and water currents that turn wind turbines and power hydroelectric dams. Meanwhile, the rays of the sun also help the plants grow that ultimately become wood, coal, and gas. What if we could cut out the middleman to open the most direct path between the sun and the energy we use every day? Let's take a step back so we can understand the real power and potential of the sun. The sun is a massive, flaming sphere of gases, 330,000 times more massive than the Earth. At its core, the sun is 27 million degrees Fahrenheit, which is 60,000 times the temperature of your oven when you bake a pizza. The sun gives off lots of energy into space as heat and light, called solar energy. If we could capture all of the solar energy that reaches the Earth's surface, we could continuously run a 25-inch television on every square meter of the Earth and still have energy left over. Right now, we aren't using all this energy. Instead, we mostly rely on coal, oil, natural gas, and other resources. But these sources aren't renewable, which means they'll eventually run out. In fact, if we keep using these non-renewable resources at the rate we are now, we may run out of oil and gas in the next 50 or so years, and coal in the next 115 years. Not only are these non-renewable resources going to run out, they're also polluting our planet and contributing to climate change. The sun's energy, on the other hand, will not run out for the next 5 billion years. That makes it a renewable resource. Other renewable resources, like wind and water, can also provide us with energy. But even all the energy we can get from all these sources added together is still less than 1% of the solar energy reaching the Earth. It's clear that the potential of solar energy massively outshines its competitors. How exactly do we harness solar energy? Solar panels directly convert sunlight into usable electricity using special materials like silicon. Another way to harness solar energy is through a process called concentrated solar power, which uses thousands of mirrors to reflect sunlight onto a tower. The heat captured in the tower makes steam that flows through a steam turbine which generates electricity. But even though we have these promising technologies to capture solar energy, there are still many challenges with using solar energy on a large scale. For example, The amount of solar energy we can harness can change based on place and time. Some parts of the world get much more sun than others. Solar panels in the Sahara Desert will produce more energy than those in Seattle. But even in the sunniest places, the sunlight still isn't constant. The changing of seasons, the cycle from day to night, and even clouds in the sky can reduce the amount of available energy. To make solar energy usable when and where it's less available, we need to improve energy storage and transmission systems. Above all, we also need to make solar technologies more efficient and less expensive. Currently, less than 1% of all energy produced and used in the United States comes from solar energy. But as more researchers, private citizens, entrepreneurs, and government agencies are recognizing its amazing potential, we're moving closer to a solar-powered society every day. The more we advance our use of solar energy, the brighter our future can be.
Hopefully you enjoyed the video on what is solar energy. You had a chance to see the various forms of renewable energy, some like wood and coal and oil, but sometimes is referred to as fossil fuels. Energies that are not necessarily the greatest choice because they harm they harm planet Earth and they harm us in the form of the greenhouse gases. So, and you saw then other forms of renewable energy like wind and water, where the sunlight produces the wind and heats up planet Earth, produces the wind, and we can convert that into solar electric energy. And that's kind of where we're going with the next lesson. So what I would like you to do is prepare for next week's lesson by looking around your neighborhood and seeing if you can locate one of these solar yard lights that's being discarded, being thrown away. So they all have a battery in them, and many times it's the battery that goes bad in these solar garden lights, and the solar cell on the top of the light is still in good shape. And that's what we want to use for next week's experiments, and some experiments after next week too. So if you can locate one of these in your neighborhood that's being, again, discarded, thrown out, naturally you need to check if it's your parents throwing it out, you need to get their permission. If it's your neighbor who's throwing it out, you need to get their permission. Just don't assume that it doesn't work. Besides that solar light, you will also need a small Phillips screwdriver. And I know that's not easily to see on the screen, but if you can find a small Phillips screwdriver, because we are going to literally take this thing apart. We're going to disassemble it. And as you can see, there's some screws in there that we need to take out in getting to the solar cell, which is in the top here. So look forward to seeing you next week. Enjoy your week and stay safe. Thank you.